Hey there, fourth graders. So today we are going to do all about line plots. And we're going to cover 3 areas of line plots all in this same video, okay? So the first is going to be how to create a line plot from a set of data. We're going to talk about what the different parts of the line plot mean so we can analyze the line plot and then also be able to answer questions about the line plot. So that'll be kind of the third part. All right, so when we are creating a line plot is essentially a number line that has data on top of it. And so we have collected some data. In this case, it's the amount of time that students have spent reading. All right, so what we want to do first before we make our line plot is find the biggest number and the smallest number, because the line plot has to at least start with the smallest number and go up to the biggest number. In this case, because we're doing fractions, we also want to look at what the denominator is on our fractions so we know how many spaces to put in between the whole numbers so that we can represent all this data on the line plot. So when I'm looking at this, it looks like the smallest is 1 3/4, and then the biggest looks like it is 3 2/4. So I am actually going to start my line plot at 1 and go up to 4. Just that way, I like to deal with whole numbers mainly. So 1, 2, 3, 4, and then my denominator for all my fractions is 4. So I have to have the 4 spaces in between each of my whole numbers. All right. My line plot also needs a title up here. This would be time spent reading. Usually it's going to be the same title that your chart has, and this is time in hours. So that way we know what those numbers stand for. All right. And now you're going to put your data onto the line plot. So we're actually going to represent each of these students with either an X or a dot. You can use either, it doesn't matter, and you'll see both. So either way, you're doing an X or a dot for each student, and you want to stack those dots or those X's on top of each other if there's the same number, and I'll show you what that looks like, because this is going to end up kind of making this chart just a lot easier to look at and analyze. So let's look at what that looks like. So we have 2 1/4. Remember, this is going to go after 2, and if you remember when we did our PLG group, we talked about 1/4, 2/4, 3/4 a whole. 1/4, 2/4, 3/4 a whole, right? So 2 1/4 is going to go here. I'm going to use an X, and I always check it off after I use it, so that way I know, okay, I've taken care of that one. Here's 2, that's right over top of the whole number 2. 3 2/4, so we find the 3, and we have to go 1 2/4 after it. 1 3/4, so again we find the 1, and we go 3/4 after. 1 2 3/4. 2 1/4, all right, 2, here's 1/4. Since there's already an X there, I'm going to put this X right on top of it. 2 3/4, so here's 2, 1/4, 2/4, 3/4. Here's 2 1/4 again. 3. 2 2/4, so here's 2, and I go after it 1/4, 2/4, and 2 1/4. All right. So now I have all of my data on my line plot. I've created a line plot from this data. Now I want to look at this and see what I can learn. Okay, we've already said the shortest amount of time spent reading, that's the smallest number, was 1 3/4. The longest amount of time spent reading is 3 2/4. The most common amount of time spent reading, that's the one that has the most X's, is 2 1/4. Okay, so we can kind of look and see where the most common amount of time is, the greatest amount of time, the least amount of time. We could also see if there's an outlier. An outlier would be a piece of data that's really far away from the rest of it. You might say that this is an outlier, this 3 2/4, because it's more than one space away from anything else. It's not super far outlying, you know, something like 4 hours would be way far away from the rest of the data, but it is kind of out there on its own. Okay, so that could be considered an outlier. Again, an outlier is just a piece of data that doesn't really match the others. And depending on what you're doing, if it's a science experiment, for example, the outlier might signify, oh, maybe there was a mistake made when I was doing the experiment, something like that. Okay, now I can also answer questions. Like if I wanted to know what is the difference between the most amount of time spent reading and the least amount of time spent reading, I'm going to subtract the biggest amount of time and the smallest amount of time, because what is the difference means to subtract. So the most amount of time spent reading was 3 2/4. This is also going to give me the range of my data. The range is how far it spans. Okay, and then I'm going to subtract 1 3/4. All right, so this is going back to our subtracting with mixed numbers. I have 2/4 minus 3/4. Remember, I can't do 2 minus 3, so I actually have to regroup. That turns into a 2. I'm going to add a whole, because that's what I took away from this 3. I took a whole away, and so now I have 6/4. Cross that out. So 6/4 minus 3/4 is 3/4, and 2 minus 1 is 1. So the difference between the most amount of time spent reading and the least amount of time spent reading is actually 1 3/4 hours. And you guys might notice that the person who spent the most amount of time reading here, Sarai, she spent double the amount of time reading as the person who spent the least amount of time reading, Camille. Okay, so that could be one way that we're answering questions. But essentially, anytime you're answering questions on a line plot, you're just looking at the line plot and you're finding where it would be. Let's say we had another student in the class who joined us named Matt, and Matt spent 2/4 of an hour more than the least amount of time. He spent 2/4 of an hour more than the least amount of time. So the least amount of time was right here, right? And he spent 2/4 of an hour more. So I can do this two ways. I can take 1 3/4 plus 2/4 to find out where Matt would go. 3/4 plus 2/4 is 5/4. All right, and then 1 plus nothing is 1. But remember, I can't have a mixed number with an improper fraction, so I have to change 5/4. Oh, that's the same as 1 1/4, so this would actually be 2 1/4. All right, so he would go here, right, with everybody else, right? Lots of kids spent 2 1/4 hours reading. Or I could remember that each of these dashes is actually worth 1/4. And so I can actually just go where the lowest amount of time reading, and I can count up 2/4, 1/4, 2/4. Okay, and I would know that the x goes here over 2 1/4. So those are just a couple of different question types that you might see when it comes to line plots. Again, it's really important that you really understand number lines and fractions. So what I want to do really quickly as I wrap this up is just go back over putting fractions on a number line. Now, we did do this in our PLG group, so hopefully you guys remember this. We've also done this in earlier units, but when you have the number line, okay, if I have 0, 1, and 2, those represent my whole numbers. And then these dashes in between the whole numbers stand for fractions. And you have to figure out what that fraction is going to be. Now, when it comes to number lines, you're only going to see halves, which is as a denominator of 2, fourths, the denominator is 4, or eighths, which has an 8 for the denominator. Okay, so you just have to figure out which one it's going to be. In each case, you're going to count how many sections or spaces there are between the whole numbers. Not how many dashes, how many spaces. So here's a space. This is 1, 2, 3, 4, which means the denominator for each of my fractions is going to be a 4. And then the numerator just counts up. 1, 2, 3. Remember, 1 whole is the same as 4/4. Okay? After you pass the whole number, now we're going to be writing mixed numbers, okay? We start our fraction counting over again, but we just have to put this 1 in front of it. So 1 1/4, 1 2/4, 1 3/4. Okay? That would be an example of a number line with fourths. Let's look at another one. All right? I'm just going to do it the same whole numbers again. Sometimes I like to put my whole numbers in boxes if it's on a piece of paper, because it just helps them to stand out a little bit, especially when you have a lot of dashes, okay? Okay, Now, I want to figure out what my denominator is going to be. Well, remember, I told you it can only be halves, fourths, and eighths. This is what it looks like if it's fourths. This is definitely not just halves, right? There's not just two spaces, all right? But we're going to just double check. So we have 1, 2, 3, 4, 5, 6, 7, 8 spaces, which means my denominator is 8. And remember, they just count up. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then we have one whole. Oops. 1, 2, 3, 4, 5, 6. I put too many dashes, guys. Sorry about that. All right, and then we have 1/8, 1 and 1/8, 1 and 2/8, 1 and 3/8, 1 and 4/8, 1 and 5/8, 1 and 6/8, and 1 and 7/8. Now you can see why they probably don't write all of these numbers usually when you're looking at a number line, because that's a lot of information. It's hard to read. Okay, so usually they'll leave stuff unlabeled. Your whole numbers will be labeled. Sometimes the halves will be labeled. But when you're having eighths on there, it's just a lot. So again, make sure that you're remembering line plots are only going to show halves, fourths, and eighths. When we're looking at the line plot, we want to think about, which number is the biggest. Whatever this is down here, if it's asking you a question about which is the most amount of time, that's asking what's the biggest number that has an X over it or a dot over it. If it's asking about the least amount of time, what's the smallest number? If it's asking which one has the most students, the X's are the students. So it's important to remember what the numbers stand for and what the X's or the dots stand for. And when you're reading the question, read it carefully. A lot of students make mistakes in line plots, not because line plots are difficult, but because they're not reading the questions carefully. So please take your time, read the questions carefully, remember how to put those fractions on a number line, and as always, if you have any questions, please feel free to reach out. Have a great day, guys.